So there's just a couple questions that people had that I thought were pretty good. So what occurs to the skeletal muscle due to aerobic training? So if we're talking about changes, we're obviously going to see more of an expression of type 1 muscle fiber. So our hybrid 2A type 1 fibers are going to go more to the type 1. Our hybrid 2X, 2A are going to be more 2A. And then our jump fibers that can do all three are going to be more type 1. We're going to increase the amount of mitochondria. We're going to increase the amount of enzymes related to aerobic metabolism. And we're probably going to increase our glycogen stores and our fatty acid stores, along with we're probably not going to be increasing that cross-sectional area too much, but that's just kind of the nature of the beast with that stuff. Now, how does blood distribution change with exercise intensity? So remember, as exercise intensity goes up and up, we're going to shunt blood away from the digestive tract and the bones, and we're going to send, obviously, most of it to our muscles. We're going to increase the total volume of blood going to our heart, but the actual percentage stays the same. The total volume going to the brain stays the same, but the percentage goes down. And we're going to increase the amount going to the skin to a certain extent, then it's going to go down. So this is important for two things. Once we get over 60% of our VO2 max, we do a really bad job of sending blood to our GI, so digestion is going to slow down, and we're going to have those issues with cramping. We're also, once we get over that probably 80, 90, now we're barely sending much to the skin, so we're not going to thermoregulate very well, so it makes it really easy to overheat. How does reliance on one energy system shift or to another shift when exercise duration increases? Well, remember, as we go up in duration, we got to go from that ATP-PCR, anaerobic glycolysis, aerobic glycolysis, and beta oxidation. We're always using all of them, but the key is we're just going to go on that max sprint, and then we're going to slow down because we're going to anaerobic glycolysis. And we're going to slow down even more because we've just kind of hit that bonking anaerobic part. So we're only left with aerobic glycolysis. And if you keep going for like maybe 2 hours or less than that, if you're going to super high intensity, we're going to be left with just beta oxidation. How's the body get rid of heat or gain it? Conduction, convection, radiation, and evaporation. We're using evaporation the most when we're exercising, radiation the most when we're at rest. The body adapts to hot temperature training, where we're going to sweat more as fluid, we're going to sweat less sodium and chloride, and we're going to sweat earlier. And how can exercise intensity increase the risk of negative health outcomes from training the heat? Like we talked about earlier, higher intensity, the lower the blood flow to the skin, the more issues you're going to have with thermoregulation. What is calcium? The question is, what is its importance? It is the protein that's going to bind to calcium inside the sarcoplasmic reticulum during relaxation. So it's really important to keep calcium out of the sarcoplasm, so we're not just contracting for no reason. Rate limiting steps of the different energy systems. Damn, that is a good question. So for glycolysis, we've got phosphofructokinase, which is going to be that third step there. Then we've got both succinate dehydrogenase and citrate synthase in the citric acid cycle, and effectively hexokinase a little bit, but remember that's step one. This is kind of getting it into the body. And why is it important? Because it turns out after that, it tends to be one way and we're not going back. So we want to have that negative feedback loop so those enzymes are being controlled, so we don't just have runaway reactions, because you never want a positive feedback loop in the body if you can help it, because obviously that's going to naturally destroy you because it just goes without any stopping. Henneman's size principle, and why is it important for training? Now remember, that is going to be how we recruit those muscle fibers. So we are always going to start off with those slow twitch fibers that are going to motor units that are going to contract a smaller number of slow twitch fibers. And then we're going to get into those bigger type 2 motor units that literally contract more fibers at the same time and more powerful. So anytime we do a movement, we're trying to do it as aerobically low intensity as possible, unless we're telling our body otherwise. We want to, when we're training an athlete, teach them how to tap into everything they need to tap into. So going slow is fine, but if we're trying to be sports specific and action specific, we've got to, at some point, have them do true maximal efforts and then have them learn how to control those maximal efforts, because we're actually going to be recruiting all those fibers so we can deliver the highest velocity possible. How is lactate cycled around the body and removed from circulation? Now, remember, guys, our type 1 fibers, along with our liver, heart, brain, a couple other structures, are going to be able to use lactate as a fuel. So once it goes into the bloodstream, it's going to go ahead and be taken up into those cells and then converted back into pyruvate and used aerobically in the citric acid cycle inside of those cells. Importance do MCTs have for this, which is monocarboxylate transporters, remember those are going to be what get the lactate out of typically the type 2 muscle fiber that's creating them and help get them into the type 1 muscle fibers so they can then be utilized as a fuel. How do our hormonal levels change with exercise? What effects can these levels? Oh, wow. Well, I'm going to imagine that was meant to say is like, what can affect these levels? So obviously the intensity of the exercise. So you can have changes in testosterone, growth hormone from like resistance training and higher intensity and higher volume work. Irregardless, whatever work you're doing training wise, you're always going to increase cortisol release, which, you know, is a stress hormone and we don't want to be bathing in it. We're going to obviously have a dump of epinephrine based upon our exercise intensity and duration. So the higher intensity, the higher amount of epinephrine, norepinephrine, the longer the duration, same thing. Insulin levels should be going down, glucagon is going up. If you're doing a crazy amount of exercise, you might have issues with suppression of your T3, T4. That's pretty unlikely. And then obviously low oxygen levels from doing chronic, moderate to higher intensity aerobic work is going to cause erythropoietin to be produced from those kidneys, which in turn is going to help increase your red blood cell. And don't forget, we always have aldosterone and all antidiuretic hormone, angiotensin and tensinogen, and all the hormones that are related to our essential electrolyte and fluid levels. So those are going to be obviously released a little bit more when we have that water loss due to sweating. So that way we're not going to be losing too much fluid through our urine, which in turn is going to possibly lead to dehydration. So that runs through all the questions you guys had for me. Alex, is there anything that I can talk about or touch on that we didn't just go through briefly there?
Yeah, sorry. I'm gonna try to say this as quick as possible. So earlier you mentioned about how blood flow kind of like leaves the GI tract when doing exercise.
Mhm.
And I want to know, do you know why it is that it's probably unrelated to anything, but do you know why, like, after someone does like a marathon, like they sometimes just have to really go to the bathroom, just let everything out?
Oh yeah, like diarrhea and otherwise. Oh, that's completely normal. So
Why does that? Yeah.
it's effectively what you're doing with when you're doing crazy long distance. Think about it. You've just done 26.2 miles of bouncing your GI around inside of your body. And that in and of itself is a stressor. You're not getting as much blood flow to your GI. Now remember, it's distribution. So you're vasoconstricting, so you're not sending as much blood to your digestive tract. And that's also a stressor on your GI. And doing that for long enough, obviously you can have some issues with, shall we say, fluid uptake and otherwise. A lot of them are using a lot of simple carbohydrates and taking down fluid and electrolyte beverages, which if you're doing a lot of simple sugar and things like that, otherwise it's probably also going to have a bit of a laxative effect. And so effectively that's, as you'll learn in bioenergetics, when we get into the physiological, mechanical causes of GI distress, that is pretty much textbook. So yeah, higher intensities, you don't have the blood flow to your GI, and it's obviously it's stressful on. Same thing if you just took a bunch of punches in the gut. The next day your GI would have issues. In fact, sadly, not sadly, but a reality of boxers is it's pretty normal for them to pee blood the next day from taking a lot of hard hits in the kidney. You've done damage to your nephrons, and there's been some blood that's leaked through those capillaries, and now it's in your urine. So yeah, that's completely normal. So, a good question.
Cool. Thank you.
No, appreciate it. Yeah, that's all I got for you guys. So some good review questions. Hope those are useful. Obviously didn't touch on the best, and the grammar is not the best there, but hey, you know.
Yeah, if I can vouch for everyone, it's just like when we're under time and we have to answer like 10 questions, everyone's just like, oh crap, what do I think?
No, dude, it's okay. It's okay. So keep sending me more questions and we'll do another short review like this next Monday. And otherwise, stay safe out there, bud, and I will see you later.
Perfect. Thank you so much. Have a good one.
You too, Alex. Bye-bye.